Hello, I am Jen, and what I do, I turn IPv4 off and turn IPv6 on for a living. Why is my talk about DNS then? Well, I have a confession to make. This is obviously a clickbait title. What I am really going to talk about, hold on, yeah, what I'm really going to talk about is stopping using DNS64, and maybe not completely yet, but just for a specific purpose for discovering NAT64 prefixes. Okay, first of all, my apologies to people who've been deploying IPv6 only networks for a while. You probably know most of things I'm going to put on my slides. However, I'd like to spend some time to explaining the basics to make sure we are all on the same page. So let's say I'd like to take away IPv4 addresses from endpoints in my network. What's going to happen? The biggest problem I'm going to face is that my IPv6 only clients probably need to reach some IPv4 only internet destinations, because I can fix my network, but I clearly cannot fix the whole internet. Well, I've tried. So when such a client trying to talk to an IPv4 only destination, it will try to get quad A record from DNS for the given name, would fail to get such a record because resource is IPv4 only, and as a result, the client would not be able to send any packets, right? So people who needed to deploy IPv6 only networks, mostly mobile operators, came up with a nice solution, right? Nice hack. It consists of two elements, DNS64 and NAT64. DNS64 is a special form of DNS which lies to a client. When client asks for a quad A record for a name which does not have one, the DNS64 server would actually return the quad A record, which it would generate by combining a dedicated so-called NAT64 prefix /96 with 32 bits of actual IPv4 address from an A record in DNS. So for the client, it's just a normal quad A record, so it will use it to send packets. And then somewhere in your network, there is a NAT64 device which will translate packets which have a NAT64 prefix in the destination, extract the actual IPv4 destination by stripping NAT64 prefix, and send those packets to the destination. And obviously, the return traffic will be translated. The key thing here is the DNS64 and NAT64 need to work together. They need to use the same NAT64 prefix. There is a well-known IANA allocated 64FF9B/96, but it actually could be any other one, and this is important. So all looks good, right? Why we still using that IPv4 thing is that, right? Why have not we migrated everything to v6 only? Well, first of all, DNS64 is obviously a hack, right? Necessary, but still a hack. And I'm sure that every single DNS person in the room hates DNS64. So what's wrong with it? First of all, if you just rely on DNS64 and NAT64 for your IPv6 only solution, there are multiple things which can go wrong. First of all those IPv4 only applications, which, for example, might hard code IPv4 addresses in the code. So DNS64 only works if your client actually using DNS. If you have hard coded IPv4 addresses in your application, well, DNS is not used, DNS64 is not used, and your client obviously cannot send any IPv4 packets on the network. The same actually happens if you, for example, try to, I don't know, ping an IPv4 address. Ping would obviously fail, your support people get tickets, unhappy customers, and so on. So another thing which could possibly go wrong, similar, is some IPv4 only applications do not even ask for quad A. They try to resolve the name, they only ask for A record. So DNS64 has no chances to solve your problem and respond with synthesized query record, it would tell the client the truth that here is your IPv4 address, but it doesn't help. What else? Oh, this is actually quite common, and it's getting more and more critical every day. So DNS64 should obviously use the same prefix as NAT64. So normally the network provides the client with DNS64 addresses they should use in form of RDNSS or through DHCPv6. What happens if the client completely ignores DNS servers provided by the network and the client, like operating system or the application, actually prefers to use some third-party DNS servers which are located somewhere outside of your network? For example, client might have Cloudflare or Google DNS configured, or even worse, it could be a corporate policy enforced on the device, which forces the client to use their corporate DNS all the time. Those DNS servers obviously are not DNS64, have no knowledge about NAT64 prefix in the network, so the client cannot benefit from DNS64. So, and the favorite point of almost every DNS person, DNS64 tells lies, right? It does not tell the truth. It would return you query record when there is actually no query record for IPv4 only name. So it's fundamentally incompatible with DNSSEC validation. And if the client is trying to run DNSSEC validating resolver, well, that's not going to work very well, right? So mobile operators who needed to deploy v6 only networks long time ago came up with a better solution, which was supposed to solve problems for IPv4 only applications. So if your application cannot use v6, for example, it does not ask for quad A or use v4 literals, 464xLAT solution introduced another element to the network. In addition to NAT64, which is located somewhere in the network, normally at the edge of the network, and does translations from v6 to v4, each client would run a customer-side translator, CLAT. That application, or part of the kernel, it depends, would basically present your applications on your host with IPv4 address and IPv4 default route. So all applications are tricked to believe that, I have IPv4, actually, I can use IPv4. And those IPv4 packets would be translated before sent on the wire to the network. Again, and this is why I'm here, that CLAT, customer-side translator, must use the same prefix for translation, right, for translating v4 to v6, as your NAT64 translator, which translates v6 back to v4, right, because obviously they need to work together. So, just to reiterate, the key elements of 464xLAT, and believe me, if you want to deploy v6 only network, you need your clients run 464xLAT. I've tried. If you do not rely on 464xLAT, if you have clients which just rely on DNS64, it's highly likely that you're going to find a lot of broken applications. So we have customer-side translator and provider-side translator, and they need to use the same prefix. Again, that prefix quite often is just well-known 64FF9B. However, there are scenarios when you might want to use network-specific prefix. You might take your address space, use slash, oh my God, it should be actually 96 here, obviously, not slash 64, sorry. So that prefix can be network-specific. If you have any modern Android or Apple device, your device probably runs CLAT already. So this screenshot is taken from the RIPE network when I was attending the RIPE meeting last time. So my MacBook was on IPv6 only network, and it was, as you can see, was running CLAT. So it was created dedicated address for that. And most importantly, if config tells me that CLAT successfully discovered NAT64 prefix 64FF9B, How did that happen? How could client know that? Because configuring NAT64 on your network is easy, right? You just push one config to your Juniper or Palo Alto, whatever NAT64 solution you are using. But provisioning every client with NAT64 prefix is a complicated task. What mechanisms do we have? More than 10 years ago, RFC 7050 was published, which defined such a mechanism. Very simple. To build IPv6 only network and to let normal, properly written applications which use DNS trying to resolve Quad A first, you probably have DNS64 in your network already. And DNS64 needs to know NAT64 prefix to synthesize names. So what 7050 proposed is to resolve a special IPv4 only name, IPv4 only ARPA. And if you get a Quad A record back, it means you are using DNS64 and here is your prefix. So let's say I'm connecting to RIPE network, which was IPv6 only. I am getting DNS server in RDNSS option. And this DNS server is DNS64. So if I'm using a normal DNS, let's say Google public DNS, and I'm trying to resolve IPv4 only ARPA, I can see that that name has A records, but there is no Quad A records for IPv4 only ARPA. But if I'm using the network provided DNS, it, as any DNS64 would do, returns to Quad A records for this. And by knowing A records, my host might know what NAT64 prefix is used. 64FF9B in this case. Easy, right? What could possibly go wrong here? First of all, we're relying on DNS here. And DNS is kind of, slightly insecure. And 7050 is a bit hand-wavy about how can we protect that method of prefix discovery from spoofing attack. What prevents an attacker to respond with wrong pref64, one which is not actually used by a network, right? It's very easy to spoof a DNS response. Well, one of the proposed mechanisms was build a secure channel, whatever it means. Like VPNs, well, I've never seen people using VPNs to talk to DNS outside of maybe enterprise environments. So yeah, it was a bit unclear. And using DNSSEC with 7050 is, well, I would not say impossible, but very hard. I have never seen anyone doing this. So what else could possibly go wrong? Surprisingly, we're going to see the same issues as I already mentioned if your host is configured with using its own resolvers, running a local resolver or configured with enterprise resolvers and so on. It would not use the network provided DNS server to resolve IPv4 only ARPA, so it would not get the prefix correctly, right? Again, this is screenshots I took on a RIPE meeting last October. My MacBook was running its own local resolver, and as a result, I'm trying to resolve IPv4 only ARPA, and I'm not getting anything. So at that point of time, people started to think about, can we improve 7050? Can we make it better? Can we make it work with DNS over HTTPS, DNS over TLS, and so on? Well, first of all, there are other fundamental issues with using DNS to discover pref64. First of all, it introduces at least one RTT delay, right? So on top of all other delays in initializing the network stack, host now needs to send DNS request, get DNS response, and only after that, the host can discover prefix and start initiating CLAT. Well, it might not sound like a long delay, but some users disagree. Another problem is after the client discovers the prefix, there is no way to ask the client to rediscover it. The client will only try to rediscover the prefix after the TTL for the Quad A record expires. And if, for example, it was a successful attack and an attacker managed to send you a spoofed DNS response with incorrect prefix, with a high TTL, well, the only way to actually reset the network stack would be disconnect and reconnect the client, which might not work very well in the large scale. So, do we have better options? Well, apparently we do, until at least for the last 5 years. As we know, IPv6 stateless auto configuration allows the host to receive all configuration information which it needed to configure its network stack in one packet. Router advertisements sent by routers and contain all that information. The default gateway address, 64 prefixes to configure addresses from, DNS servers, MTU, MAC address of the router, and so on. So why could not we just add one more thing there and provide NAT64 prefix in router advertisements? So host getting everything in a single packet. Yeah, so that's why we published RFC 8781 almost 5 years ago. I might be, full disclaimer, very much biased here because I was a co-author of 8781, but let's compare them. Let's compare two methods of discovering NAT64 prefix. One is RFC 7050 by resolving a name, and another by including Prefix4 in router advertisements. So, security. DNS response can be spoofed, and it's really hard to prevent. If you include everything in router advertisement, you at least have a fate sharing, right? If in your network an attacker is capable of sending rogue arrays, well, you're in trouble anyway. And NAT64 is a least of your concern, really. Because, yeah, you need to have a fundamental router advertisements protection on your network to ensure only legitimate routers can send arrays. Compatibility with third-party resolvers. Like, again, it's getting more and more important as more and more applications trying to use application-specific resolvers. If you're using 7050, your clients must use network provider resolvers, at least to resolve IPv4 only ARPA. There is a recommendation that if you have third-party resolvers configured, you always need to use network provided resolvers just for resolving IPv4 only ARPA, but I have not seen any implementations which actually does that. So it doesn't work very well. If you provide a Prefix4 in router advertisements, then, well, doesn't matter which DNS servers your clients are using. Using router advertisements, again, much faster in terms of initialization, and it's easy to control for network administrator. You need to change it, you send another router advertisement with updated information. So very quick. So in other words, if you deploy in IPv6 only networks, it is strongly recommended to provide Prefix4 in router advertisements to the clients. Most commercial router vendors like Cisco, Juniper support this. Open source, there are implementations as well. DNS64 in all cases for IPv6 only or IPv6 mostly when you have mix of dual stack and v6 only clients, you might still need to provide DNS64, especially in v6 only network, right? Because in v6 only networks, you need DNS64 unless all your clients support Pref64. If you do in v6 mostly networks, which means only clients which sends DHCP option 108 becomes v6 only, in this case, it's actually pretty safe to get rid of DNS64 currently, because as far as I know, all implementations which sends DHCP option 108 and as a result would become v6 only in such a network, they also support Pref64. And all other clients will be dual stack, so they don't need DNS64. I think in one of the recent RIPE meetings, NOC ran an experiment. They disabled DNS64 on v6 mostly network, and the results were quite positive. So DNS64 can be made redundant in IPv6 mostly environments. If you are a developer, please rely on Prefix4 instead of resolving IPv4 only ARPA, at least as a primary method. Resolving IPv4 only ARPA might still be necessary for time being, but the goal is to get rid of it. So why I'm here actually? Because we already have 2 competing standards. We don't want to have 3 competing standards. There is a currently document adopted by IETF v6 Ops Working Group, which does not say anything fundamentally new. It basically reiterates those recommendations, which I just mentioned, which is saying, if you deploy in such a network, please provide Prefix4 so we can eventually get rid of DNS64. And if you are net developer for endpoints, for hosts, please implement support of Prefix4 currently. What we're trying to achieve here? We're trying to get to the point when we can get rid of DNS64. It has been very useful, more than that, but at this stage, I believe we might be able eventually to get rid of it, which would make a lot of people happy, especially people working with DNSSEC, right? Oh, a disclaimer, I actually wanted to have a slide about that, but I forgot. If you are mobile operator, you're probably wondering right now, what about 3GPP networks? 3GPP networks, mobile networks, are special case. There is no currently configuration option to provide Prefix4. There is ongoing discussion about how we shall work with 3GPP community to change that. But in mobile networks, at least currently, I guess some of those concerns about 7050 is less applicable. There is a less chances of getting DNS spoofing attack and so on. But at least for Wi-Fi, public Wi-Fi, enterprise networks, conference networks, there is a currently quite a good chance if you just started to deploying it, maybe you can do it without DNS64 right away, right? Because deploying it with DNS64 and then turning it off later, it's a bit of scary. I've done that and I'm still horrified by the idea. So again, please read the document. It's actually quite short. If you go in to deploy IPv6 only network, please think about using Pref64 instead of DNS64. And if you are not going to deploy IPv6 only network, I'm surprised why. Why are you using that legacy protocol still? So I think I am quite good on time, right? So we have what, like 6 minutes for questions, comments?
Thank you. Any questions?
Everyone busy deploying v6 only, right?
Please come up with questions because I have really boring content to fill in. So it's for your own protection.
Hey, good afternoon, Darren Carr, Quad 9. I was just wondering if the
Alter voice.
other voice?
Yes.
Is this better?
Yes,
Okay.
definitely.
This seems like it's a follow-up to in the early 2000s when trying to deploy IPv6 only network. The TOT-D daemon, trick-or-treat daemon that would do this synthesizing the records as you're discussing. Is this follow-up to that work from the early days, and or you have anything to do with that in the early days? Thank you.
No. So yeah, so I do not have anything to do with that, right? So here what we, I probably need to give you a bit more background, right? So currently, based on my experience in deploying IPv6 only and IPv6 mostly networks, we realized that you probably wouldn't be able to deploy it without CLAT, which not necessarily just do local synthesis, right, for the names. it basically provides you with a full IPv4 stack on a host which is not visible to the network, right? And for this, we need Prefix 4. There are APIs from some operating system which just do local synthesis in terms of DNS, and they also use Prefix 4 for that reason. So actually, I'm not sure I actually answering the question you asked, but feel free to follow up offline. My email is on the slide.
All right. I guess that's not a question. Anybody else? Questions? All right. I want to remind you we have the hackathon going on. And we are actually, is that correct? Because it says 9 minutes, and on my watch I see 4 minutes left to the next talk.
Should be 4.
Yeah, I think it's 4.
But, well,
Yes.
I think it's everything was clear.
Well, thank you, Jen.